There's one more thing we want to add to activity number 2 in our notes. And that is a sketch of hydration shells. To make this sketch, we're going to start with our salt molecule, NaCl. And we're going to say that we're going to put this molecule into water. So we can draw it. I'm going to draw it a little bit bigger with a longer extended bond here. Because what I want to show is that for an ionic bond, the electron is taken, not shared like it would be for a covalent bond. So I'm going to put my electron to remind myself that chlorine is taking this electron from sodium to create an ionic bond. I'm going to put an electron here. So what's going to happen is that the chlorine, because the electron comes with a negative charge, it's a package deal, chlorine is going to be slightly negative. Sodium, on the other hand, because this electron has been taken away from it, it's going to have a slight positive charge. When we were talking about our water molecules, we said that water molecules have dipoles. So we have to remember opposites are going to attract, positive and negative. So I'm going to draw in some water molecules around the sodium. And because there's a negative dipole on the oxygens are going to want to stay very close to that sodium. So our positive dipoles are all over here. But what we care about is this oxygen, this negative dipole being attracted to the positive charge that's on this sodium. It's starting to surround this sodium. On the other side, our positive dipoles from the hydrogens are going to be attracted to the negative charge on the chlorine. So what you're going to see on this side is that the water molecules orient themselves so that the hydrogen and that positive dipole are closer to that negative charge. Closer to that chlorine with a negative charge because the electron is spending more time over here and electrons are negatively charged. You get a lot more of the hydrogen, that positive dipole of the water, coming closer to chlorine. This is how we start forming our hydration shell. What happens next is that more and more water molecules want to join in. More of those oxygens want to get a piece of this positive charge. And what happens is as these come in, shove their way in, these water molecules get shoved to the side. So as these water molecules get shoved to the side, they get shoved around the sodium. Those water molecules are strong enough to break this bond. So then what you're left with is a sodium ion, and remember it's going to be positively charged, is going to be surrounded by water molecules, specifically the oxygens. Because now these dipoles are extra attracted to the positive charge of the sodium. So a very similar thing happens with the chlorine too. You get more water molecules that want to shove their way in. And because they're trying to push in, specifically those hydrogens are trying to push in because they're attracted to that negative charge. When that happens, these water molecules are pushed to the side and they're pushed around the chlorine atom. And once they're pushed close enough together, this ionic bond, like we said, is going to break. So then what happens over here is that the chlorine, now with a negative charge, is completely separated. And surrounding that chlorine, you're going to see the hydrogens from water molecules, because their positively charged dipole is attracted to the negative charge that this chlorine ion has. So now the sodium over here and the chlorine over here are completely separated from each other. This is called a hydration shell.